So some molecules are acting as a ligations. Ligation means ligands. Which type of molecules are acting as a ligand? Some molecules. So that molecules are CO, NO, N2, okay, O2, H2O. These all are what? Neutral molecules. These all are neutral molecules. So in these molecules are acting as a ligand and the formation of metal metal complexes. Especially here, CO is widely formation of the metal complexes. They are metal carbonyls. The name of that metal carbonyls. So CO is a strong ligand at the same time that is a sigma donor and a pi acceptor. So that is the formation of so many complexes. So many complexes. The complex name is the metal nitrosyl means metal n number of metal CO plus y number of CO. The formation of the Mn COY complex is formed. Mn COY means N is equal to number of metals. N is equal to number of metals. Y is equal to number of COs. This is the number of metals. The name of the complex is metal carbonyls. At the same time, NO is a nitric oxide. The name is the nitric oxide. That is also the formation of the metal complexes. That is also the formation of metal complex. This is a diatomic neutral molecule. This is also diatomic neutral molecule. CO also diatomic neutral molecule. NO also diatomic neutral molecule. Metal is bind with the NO. Metal is bind with the NO, the formation of metal nitrosyl. The name of the complex are metal nitrosyl. At the same time, nitrogen means dinitrogen is the formation of the metal complex. Formation of the metal complex. The name of the complex is metal dinitrogen complex. Metal dinitrogen complex. At the same time, oxygen and water molecule also acting as a ligand. These are the neutral molecules. Now we can discuss about the metal carbonyls. Metal carbonyls are the formation of different complexes. Different complexes that is based on the their reacted. This is based on which type of metal complex are from M N plus Y CO. These gives rise to n number of metals, y number of CO. The formation of MnCO is the metal carbonyl complex, where N is equal to what? Number of metals, Y is equal to what? Number of carbonyls, number of CO, number of carbonyls. So based on the N, we can classify the different types of metal carbonyls. Based on the N, we can classify the different types of metal carbonyls. They are N is equal to 1 means mononuclear, N is equal to binuclear, N is equal to 3, trinuclear, N is equal to 4, tetranuclear, so on. Okay. So based on that, we can classify that LNC, low nuclearity carbonyls. LNC means low nuclearity carbonyls. The another one is the HNC, high nuclear carbonyls. High nuclear carbonyls. So in the LNC, low nuclear carbonyls are M1 to M4 carbonyls. M1 to M4 means in that in the class are considered the mononuclear, binuclear, trinuclear, and tetranuclear. That is the low nuclear carbonyls. And high nuclear means more than 4 means M5. So M5, M6, M7, M8, M10 like that. Okay, that is the high nuclear carbonyls. High nuclear carbonyls. How to formation of the carbonyls? This is a classify the carbonyls are based on the number of metals. Based on the number of metals, we can divide into two classes. One is the One is a low nuclear metal carbonyls. The second one is a high nuclear metal carbonyls. So LNC means low nuclear carbonyls contain the up to four four metals. Remaining the HNC means more than four. Five, five, six, seven, eight, nine, 10, like that. Okay. So how to formation of the carbonyls? How to formation of the carbonyls and what is the properties of the carbonyls? What is the properties of the carbonyls? Sometimes mixed metals also the formation of carbonyls. Sometimes mixed metals also the formation of carbonyls. Okay. So based on the metal, different preparation methods are there. Metal is directly bind with the carbonyls. Directly bind means, so we are using some conditions. Based on that conditions, what is the conditions? Sometimes we can maintain the temperature, sometimes we can maintain the pressure, sometimes we can maintain the pH, like that. Different conditions are there. Metal is directly bind with the CO. Based on the conditions, the formation of MnCOY, all type of carbonyls undergoes this type of preparation. That is simple method is their preparation. Okay. So in the first prepared metal carbonyl is the nickel tetracarbonyl. The first prepared carbonyl is the nickel tetracarbonyl. Okay. Then this is the mononuclear. This is the mononuclear, like this. Here, you observe you can this structure mononuclear. And the next one is the chromium CO6. Chromium CO6. Chromium hexacarbonyl. Chromium hexacarbonyl. So different types of carbonyls are there. So what is the properties of carbonyls and what is the stability? How can you form that? This, okay. So it means what we can discuss the first nickel tetracarbonyl means the structure and what is the properties of the carbonyls. That is the form stable or unstable. Given some properties. What is the properties of that? Okay. What is the property? For example, nickel is the central atom that is bind with the or approaching the four carbonyls. Okay. Nickel, the atomic number is what? 28. Write their configuration. Argon 4s2 3d8 is the electron configuration of nickel. So what is the status of central atom of nickel? That is 3d8 4s2 4p0. This is the status 3d8 means d orbital is contain 8 electrons, like this. S is contain 2 electrons. This is the status of carbonyl. What about the nickel is approaching the how many carbonyls? 4 carbonyls. That means the nickel is accommodate 4 carbonyls, means that is contain the 4 vacant orbitals. But in how many is there? Only p orbital is vacant. That is the 3 orbitals are vacant. Okay. Here in the 4s2 is the electron pair is there. In 3d8, 2 unpaired electrons are there. So in that condition, the nickel or the central atom is some internal changes are takes occurs the some internal changes. That means what? So here electron pair is there now. This electron pair one is shifted here, one is shifted here. Then after shifting the or after rearrange the electrons, what happened? What happened? So these are all electrons are pairing is takes place. All electrons means already 8 is there. 1, 2, 3, 4, 5, 6, 7, 8. Already 8 is there. After shift the s orbital electron to the d orbital, then electron pairing is takes place. In that condition, how many vacant orbitals are there? 4 vacant orbitals are there. In that 4 vacant orbitals are undergoes to the hybridization. What is the hybridization? One s orbital and 3 p orbitals are involved in the hybridization and the formation of 4 equivalent sp3 hybrid orbitals. are same energetical hybrid orbitals. So in that orbitals are means in that condition nickel is contain the 4 sp3 hybrid orbitals. 4 sp3 hybrid orbitals. In that 4 hybrid orbitals are vacated. So each CO is donate a pair of electron. Each CO is donate a pair of electron to the central atom. Each CO is donate a pair of electron to the central atom. Then this approaching is takes place. So the formation of the like that the four coordination covalent bond. Four coordination covalent bond. What about the geometry of this? The geometry of this complex is the what is the geometry? What is the hybridization? sp3 hybridization. What is the hybridization? sp3. The sp3 hybridization. What is the common geometry? Is the tetrahedral geometry. What is the geometry? Tetrahedral geometry. Next, what is the properties of that complex? So here central atom is the nickel. That is undergoes the sp3 hybridization, tetrahedral geometry. What about the magnetic property of that? All electrons are paired. All electrons are paired in the orbit. So that means that is the diamagnetic complex. That is the diamagnetic complex. Okay. What about the stability means we can count the electrons. This is the properties of that. Okay. And we can count the EAN means end EAN. What is EAN? Effective atomic number. Okay, we can count the electrons of total electrons of that complex. What is the EAN? That is follow or not, obey or not. Okay, EAN. EAN means effective atomic number. Effective atomic number. How to calculate that? EAN is equal to atomic number minus oxidation state plus 2 into number of ligands. 2 into number of ligands. This is the equation. Further we can calculate the EAN. So what about the Z here? Z atomic number of nickel is how much? 28. What is the oxidation number? Is the 0. Okay, neutral. Metal is neutral, ligands also neutral. Plus what about 2 into? How many carbonyls are there? 4 carbonyls are there. Okay. Then you can count the EAN. 28 plus 2 into 4, 8. That is equal to 36 electrons are there. 36 electrons. That means what? This 36 is the similar to which atomic number? 36 is the similar to the krypton number. Krypton. 36 is similar to the krypton atomic number. Okay, krypton is the 36 atomic number. You can count the all electrons of in this complex. You can count the all electrons of this complex is get the 36 electron. Okay, this is similar to the krypton electron krypton atomic number. That means this complex is obey the EAN rule. That means that is the stable complex. That is the stable complex. So all COs are acting as a terminal complex. All COs are acting as a terminal carbonyls. Okay, like that. So you can observe here. This is the nickel geometry of this. Okay, the geometry of nickel tetrahedral geometry. Similarly, chromium also. That is the octahedral geometry. That is the octahedral geometry. And sometimes binuclear also is there. That is mononuclear, binuclear. Okay, different types of okay. Trinuclear also is there. Binuclear. That means CO8. Increase the metal number of metal. The metal bond is increased. Increase the number of metals. The metal bond is increased. So binuclear Fe2CO9 and CO to CO8, cobalt to CO8. This is also binuclear carbonyls. Okay, like that. You can in binuclear Fe to CO9, Fe to CO9. Okay, in this you can count the and explain the property of that. What about the Fe? Fe is nothing about the iron. What is atomic number? Fe is the 26, argon 4s2, 3d6, 4s2, 3d6. So here the number of metal bond is increased. You can observe here number of metal bond. 2 is there, metal bond is increased here. Uh, Total 9 carbonyls are there. In that 9 carbonyls, 6 carbonyls are acting as a terminal. 6 are acting as a terminal. 3 are acting as a bridged. 3 are acting as a bridged. Okay. So we can count the EN, and another rule is also, that is the 18 electron rule. That is the 18 electron rule. So we can apply the 18 electron rule in that. You can apply the 18 electron rule in the tetracarbonyl complex. Okay, then you can apply here 18 electron rule. That is also one type of rule. That is 18 electron is nothing but similar to organic electron configuration. 18 electron rule is similar to organic electron configuration. Okay, so another rule is there, 18 electron rule. In so many examples are there, you can explain there. 18 electron rule. What about the 18 electron rule? You can count the valency electrons of the complex. You can count the valency electrons of complex. In that valency electron is similar to the 18 electron rule, or follow the 18 electron rule. That is a stable complex. Or not follow that. That is a less stable complex. How can you calculate the 18 electron rule? So here 18 electron rule is nothing but 18 electron rule is equal to, so number of electrons in metal, number of electrons in metal plus number of ligands into 2 plus number of metal bond into 2 plus number of negative charge is there, we can plus negative charge into 1. Okay, like that. These are the we can write the equation of count the 18 electron rule. 18 electron rule is equal to, what is the equation? Number of electrons means which electrons? Number of valence electrons in metal. Number of valence electrons in the outer cell is contained. Valence cell is contained how many electrons? You can count that electrons. Next, number of ligands into 2. How many ligands are there? Means how many carbonyls? Ligand is nothing but what? Carbonyls. You can mention here carbonyls. Number of carbonyls. Number of carbonyls into 2 plus number of metal bonds into 2. Number of metal bonds into 2. If any negative charge is there in the complex, you can addition how many negative charges are there into 1. Okay, this is the rule for the means equation for the 18 electron rule. 18 is nothing about argon configuration. Okay, those metal complex, you can count the valence electron. That valence electrons are follow, that valence electrons are follow this rule, this configuration, that is the 18 electron rule. So this is can apply the nickel tetracarbonyl. This apply the nickel tetracarbonyl. They follow or not, we can explain that. Nickel. What is the atomic number of nickel? 28. What is the atomic number of nickel? 28. What about the electron configuration? Nickel electron configuration is argon 4s2 3d8. Okay. So what is the means how many valence electrons are there here? 3d8, not 6. 3d8. How many valence electrons are there? You can number of valence electrons in metal. Number of valence electrons in metal. How many valence electrons are there? Valence means outer shell electrons. Outer shell electrons. How many is there? 2 plus 8. How much? 10 electrons are there in valence shell of the metal. Okay. Plus number of COs into 2. Number of how many COs are there? Number of COs into 2. How many COs are there? 4 COs are there into 2 is equal to how many electrons? 8 electrons. Any metal bond is there? Metal bond is not there. Why? Because of only one metal is there. Any negative charge is there? Negative charge is also not there. Okay. You can count the electrons. You can count the electrons. Count the electrons means metal is contain 10 electrons. Valence shell is contain 10 electrons. Ligands are contain 8 electrons. Total how many electrons are there? 18 electrons is there. 18 electrons is there. So that is the 18 electron rule. This complex is obey. This complex is obey the 18 electron rule. Means this is a stable complex. That is the stable complex and gives so many spectral properties of that complex. Okay. Similar, we can apply the same equation for the binuclear complex. So we can put the another slide.
सर गुड मॉर्निंग।
गुड मॉर्निंग।
सर ये नोट्स मिल जाएगा सर?
दिस नोट सेंड कर दिया ना?
सेंड कर दिए थे सर।
हाँ, उस दिन तुमको सेंड किया, मैसेज डाले ना।
सर मेरे को नहीं मिला है सर।
After complete the class, you can call me. I will send you.
राइट सर।
Okay.
राइट सर, थैंक यू सर।
Hmm. So wait, we can put the another slide. Is just wait. So here This is nothing about the high nuclear carbonyls. High nuclear carbonyls. So in the low nuclear carbonyls are up to 3, up to 3, M1, M2, M3. M1 is the, you can observe nickel tetracarbonyl, chromium hexacarbonyl. M2 binuclear is the, so many is there, you can write Fe2CO9, CO2, CO8 is the binuclear. Trinuclear is the Fe3CO12, Fe3CO12. These are the mononuclear, binuclear, trinuclear, and tetranuclear also is there. That is the osmium-4CO12. Osmium-4CO12. These all are can explain the 18 electron rule later. So now we can discuss about the high nuclear carbonyls. High nuclear carbonyls. Okay. What is high nuclear carbonyls? High nuclear carbonyl means the metal is more than 3. More than 3. That is considered the high nuclear carbonyl. That is considered the high nuclear carbonyls. Okay. So here high nuclear carbonyl clusters. These are the formation of clusteral complex. These are the formation of clusters. So which type of these are the go in the C3V point is considered. The example is the CO, rhodium, iridium, osmium. Okay, this type of complex are formed. Okay, they are obey 18 electron rule. This is very important. They are obey 18 electron rule. Okay, you can they are obey 18 electron rule. The total electron count is CO and high nuclear carbonyl clusters. Okay, so obey 18 electron. We can count all electrons of that. After count the electron, that is obey the 18 electron rule. So, for example, M4CO12 type of complex is there. M4CO12. Okay, here M is equal to nothing but what? M is equal to osmium, rhodium, and iron. Osmium, rhodium, and iron in the formation of cobalt, rhodium, iridium. Okay, these are the formation of the clusters. Clusteral form. What is the mean by clusters? What is the mean by clusters? Cluster is nothing but one structural form of the carbonyls. One structural form of the carbonyls. Okay, so you can uh, count the 18 electron of one by one. This is the first one is the Fe2CO12. First one is the Fe. Very important. This 18 electron rule given for the examination. Very important question. The first one is the Fe2CO12. Fe2CO9, not 12. CO9. What is about the 18 electron rule? Obey or not? So, what is the central atom? Is the iron. What is the atomic number of iron? 26. What about the electron configuration? Argon 4s2 3d6. Okay. What is the central atom is contain how many valence electrons? 2 plus 8. Iron is contain the 8 electrons. Okay. What about the how many COs are there? 9 COs are there. 9 COs into 2 electrons. Total how much? 9 2 ja 18 electrons. Okay. So here any charge is there? Charge is not there. But here two metals are there. So one metal bond is there. One metal bond is there. Means metal bond into 2 electrons. That is equal to 2 electrons. We can count the electrons. Okay. Here Fe2. Each iron is contain 8 electrons. Each iron is contain or each central atom is particularly in this complex. Each central atom is contain 8 electrons. How many is there? 2 is there. 2 central atoms are there. Into 2 is equal to how much? How much? Okay. So in this complex, 2 iron atoms are there. Okay. Each iron atom 2 into 8 is equal to 16 electrons. 9 carbonyls are there. 9 into 2 is equal to 18 electrons. One metal metal bond is there. One metal metal bond is there into 2. That is equal to 2 electrons. You can count the electrons. How many is there? 8 plus 2. 10 plus 6. 16. Here 1, here 6. What about the 1, 2, 3? 36 electrons are there. 36 electrons are there. Total how many electrons are there? 36 electrons. In the 36 electrons, how many metals are there? Number of electrons by number of metals. How many metals are there? 2 metals are there. 36 by 2. That means 2 1 jar 2, 18 jar. So this is obey the 18 electron rule. Fe2CO9 carbonyl is obey the EAN rule. Similarly, so many examples are there. That is another example is what? CO2, CO2, CO8, CO2, CO8. We can observe that. What is the complex? CO2, CO8. CO2, CO8. This is cobalt carbonyl. Cobalt carbonyl. Here cobalt is the, what is the atomic number? 27. 1s2, 2s, sorry. Cobalt is the organic. 4s2, 3d7. 3d7. 4s2, 3d7. Total how many electrons? Cobalt is contain 9 electrons into 2 is equal to 18 electrons. Okay. How many COs are there? Carbonyls are 8 is there. 8. 8 COs are there. 8 COs into 2 is equal to 16 electrons. One metal metal bond is there into 1 into 2 electrons is equal to 2. This is also, you can count the electrons of this. 18 means 2 plus 8, 10, 6, 16, 1, 6. This is also 36. Means CO2, CO8, 36 by 2 is equal to how much? 18 electrons. This is also obey the 18 electron rule. That is also obey the 18 electron rule. You take any complex, means the clusters are the obey 18 electron rule, or the carbonyls are obey the 18 electron rule. That is the stable. Most probably that is obey the 18 electron rule. Okay. So like that, different nuclear is it the metal carbonyls uh, mixed metal carbonyl, mixed metal carbonyls. You can observe here mixed different types of metals also bind with the carbonyl. Different types of metals are bind with the carbonyl. That is the mixed carbonyls. So here CO and cobalt MnCO9. Cobalt MnCO9. Next one is some mixed carbonyls are there. Okay. And Mn2FeCO12. Mn2FeCO12. Okay. Mn2FeCO14, not 12, CO14. Okay. That is the increase the number of metals. Metal bonds are increase. Then third, Fe2 ruthenium CO12. Fe2 ruthenium CO12. That is also cluster. Means the mixed carbonyls. Mixed carbonyl means what? Different metals. Ligands are same. Different metals. Okay. And another one is also there. That is the Fe Ru2CO12, FeRu2CO12. These are some mixed carbonyls, These are the formation of the clusteral form. These are the formation of the clusteral form. So very important is the 18 electron rule. Very important is the 18 electron rule. Previously, we can explain the 18 electron rule. Okay. So here observe uh, chromium CO6. Okay, that is one example. Nickel tetracarbonyl. You can observe the nickel tetracarbonyl. That is also obey the 18 electron rule. Chromium also obey the 18 electron rule. Next one is the zinc. Zinc tetracarbonyl. Zinc tetracarbonyl. That is also obey the 18 electron rule. We can observe this is a very important. We can observe the chromium. Chromium chromium CO6. Chromium atomic number is 24. Electron configuration is the argon 4s1 3d5. 4s1 3d5. How many electrons are there in the valence? 10 electrons are there. How many ligands are there? 6 ligands are there. That is the 12. 1 minute. Okay, 6 electrons are there. 6, not 10. 6 electrons are there. Chromium 1 plus 5. 6 chromium is contain 6 electrons. How many ligands are there? This is for chromium. This is for 6 ligands are there. 2 into 6 is equal to 12. That means that is the 18 electron. That is obey the 18 electron rule. Obey the 18 electron rule. That means that is the stable complex. The geometry is the octahedral geometry. Geometry is the octahedral geometry. Similarly, so many examples are there. So many examples are there. What about the means another complex is there, that is the zinc tetracarbonyl. Zinc tetracarbonyl plus 2. The charge is the plus 2. Zinc atomic number how much? Zinc is the 30 atomic number. What about the electron configuration? Argon 4s2 3d10. 4s2 3d10. Okay. So zinc is contain the zinc plus 2 state. Zinc a charge is there now. That is a zinc plus 2. Zinc plus 2. What about the zinc plus 2 configuration? Argon 4s0 3d10. After charged ion get the configuration is this. Zinc plus 2 means zinc is loss of 2 electrons and convert the plus 2 charge. Zinc plus 2 configuration is what? 4s0 3d10. 4s0 3d10. Zinc is contain how many electron valence? 10 electrons. Zinc contain 10 electrons. Okay. At the same time, how many carbonyls are there? 4 carbonyls are there into 2. That is the 8 electrons. 10 plus 8 is the 18 electron. How much? 18 electron. That is the 18 electron rule. This is also the formation of 18 electron rule. So, like that, so many complexes are there. So many complexes are there. Okay. So many complexes are there. Iron FeCO5. Okay. Next, CO2 CO8. You can see that. Next, Mn2 CO10. Mn2 CO10. Okay. Different complexes are there. Different complex are there. These all complex are obey 18 electron rule. That is obey the 18 electron rule, that is stable. Not obey the 18 electron rule, that is the less stable complex. That is the less stable complex. Okay, like that. This is the 18 electron rule. Those complex are follow 18 electron rule or obey the 18 electron rule. That is stable complex. So many examples are there here. So many examples are there. Next, the structural aspects of or binding mode of metal carbonyls. The binding mode. What about the binding mode? Binding mode is nothing but carbonyl is carbonyl CO is acting as a or bind with the different binding mode. CO is bind with the different binding mode. That binding mode is nothing about the what is that? For example, CO is a stable molecule. CO is the stable molecule. That is stable is there, and that is bind with the metal. That is the terminal mode, and that is bind with the bridged also. Two metals are there. These two metals are connected. That is acting as a bind bridged also. Next, that is connect with the acting as a triple bridged also. Triple bridged. Okay, like this. That means that is means free state is stable, or that is terminal mode, or bridged mode, or triply bridged mode. These are the formation of that is called what binding mode of CO. The binding modes of CO. How can you identify that? Based depend on the spectral properties, or based on the spectral properties. Okay, so we can that is different stretching frequency. CO is the functional group. CO is the functional group that is bind with the metal terminally or linear. Terminal or linear. Bridged. Bridged also two types of the bridged means one is the unsymmetrical bridged. Unsymmetrical bridged. The second one is the symmetrical bridged. Unsymmetrical and symmetrical. What about the symmetrical and unsymmetrical different? What is the difference between that? Symmetrical means symmetrical bridged means two metals are there. These two metals are connect with the CO. This is a bond A. This is a bond B. Bond A is equal to bond B. Bond A means bond A bond length bond angle is similar to bond B, bond length and bond angle. That is called what? A is equal to B. A is equal to B. That is a symmetrical manner. That is the symmetrical manner. Next, unsymmetrical means unsymmetrical. Same two metals are there. Metal bond is there. Metal metal. These two metals are connected with the CO. These two metals are connected with the CO. Bond A, bond B. A is not equal to B. A is not equal to B. Means A is greater than B or A is less than B. A is greater than B or A is less than B. Not equal to B. That is unsymmetrical. Bond A, uh, bond B. Both bonds are not similar bonds. Both bonds are not similar bond. That is the unsymmetrical bridge. That is the unsymmetrical bridge. These all are given for the evidence for spectral evidence. What is the spectra? IR spectra, IR infrared spectra. That is give the stretching frequency. That is give the stretching frequency. Based on the stretching frequency, this cornel is different binding modes are there. Okay. So what about free CO? That is the 2200 centimeter inverse. Their range is the 2200 centimeter inverse. Terminal CO. The range is 2100 to 2000 centimeter inverse. Okay. Bridged Bridged CO is 1800 to 1600 range there, stretching frequency. Okay. Triple bridged, that is less than or below 1600. Below 600 centimeter their range. That means those carbonyls or those CO is bind with the metal based on that stretching frequency, based on the stretching frequency. That is free is there. That ligand is that carbonyl free in there in that complex. That the range is above 2200 centimeter. Their range, the peak is obtained in that range 2200 centimeter inverse. Okay, CO is bind with the terminal mode or linear mode. Okay, the stretching frequency is 2100 to 2000 centimeter inverse. CO is bind with the bridged mode. That is the stretching frequency is 1800 to 1600 centimeter inverse centimeter. The range. That is a triple bridge. The range is below 600 centimeter inverse. This is the evidence for the stretching frequency. The binding mode is obtain the different binding mode is the carbonyls. Okay, you can observe here all points are there here like that. Here the stretching frequency, CO group, different stretching frequencies.
ଏବେ କାଣା ଯଦି କ୍ୱାର୍ଟର ସେ ଆମର ସେ ଭଉଣୀ ବି ସବୁ ଚିହ୍ନା ଜଣା ଯେଠି ଲାଗଲା 10 ମିନିଟ ଲେଟ ନିଜେ ଗାଁ ଦେଖ ହନ୍ଦାର ମତେ ତାଙ୍କୁ କହିଦେନି ରସ ହଁ ହଁ
You observe here the
ହଁ
stretching
ହଁ
frequency of
ହଁ
the modes of
କହିଥିଲେ
ligation
ଯଦି
of CO. You observe here.
ହଁ ହଁ
This is the terminal ligand. Please go to the
ହଁ ଆଉ ସବୁ ଠିକ ପଢମା ଇହାଦେ ଭେଟ ପଢମା ଇହାଦେ ପସିବୁଲ ହେବା ଭେଟ ପଢବାଟା ହଁ
the stretching frequency of
ଠିକ ଅଛି
CO. I mean the binding mode of CO. So you observe here the binding mode of CO. Binding mode of CO. Here that is this is a terminal mode. This is a terminal or linear. Terminal or linear. This is a unsymmetrical bridge. You can observe both metal is there. One bond is short bond, one bond is a long bond is there. This is a symmetrical bridge. This is a symmetrical bridge. Okay, and this is a triply bridge. Okay, three metals are connected the CO. This is a triply bridged like that. So this is the formation of the complex in different binding modes, different binding modes. So that is the formation of stable complex. That is the formation of the stable complex. Okay. So how to acting as a bridge is the bridged carbonyl form. Okay. So metal is one CO is donated the electron pair to the metal. Okay. So here the formation of this binding mode. So they're explaining the binding modes. What about the MOED of this? MOED means what? What is the bond order of CO? What is the bond order of CO? What is the bond order? What does it mean by bond order? Bond order is equal. Bond order means how many bonds are there in between the C and O. That is the bond order. And which is the donor, which is the acceptor. That is can explain the MOED of the CO. You can observe the MOED. What is the MOED? Molecular orbital energy level diagram. What is the MOED? Molecular orbital energy level diagram. You can draw this diagram. Okay, which is the donor, which is the acceptor, which orbital electron is donating, in which orbital is the accept the electron pair from the metal. Okay, MOED. That is can give the bond order of any element, bond or any molecule, not element, bond order of any molecule. So for example, hydrogen. In between the hydrogen, how many bonds are there? One bond is there. Or for example, O2. In between the O2, how many bonds are there? Two bonds are there. That is can explain the MOED. For example, N2, nitrogen. How many bonds are there in between the nitrogen? Three bonds are there, like that. Okay. So that is can explain the MOED. Okay. So that is can apply the CO. How many bonds are there? MOED means molecular orbital energy level diagram. Molecular orbital energy level diagram. Okay. So MOED of CO. So here carbon, this is the oxygen. This is the atomic orbital. This is also carbon is the atomic orbital. Oxygen also atomic orbital. This atomic orbital is contain how many electrons? 6. This atom is how many electrons? 8 electrons. Okay. So what is the electron configuration? This carbon 1s2, 2s2, 2p2. What about this 1s2, 2s2, 2p4, 2p4? You can draw the MOED of that. First, you can take the p orbital of carbon and the p orbital of oxygen. So here carbon p orbital contain how many electrons? Carbon p orbital contain 2 electrons. Oxygen is contain 1, 2, 3, 4 electrons. Okay. You can draw the MOED of this. So this is a in the atomic orbital level. To do means lower level is the bonding molecular orbital and higher is the anti-bonding molecular orbital. Anti-bonding molecular orbital. Okay, like this. So here p orbital is contain means carbon is contain 2 electrons, oxygen is contain 4 electrons. Okay, so here this is a sigma 2px sigma 2pz pi 2p 2px 2py pi 2p. This is sorry, sigma 2px, this orbital is next is sigma 2py, this is a pi 2pz pi 2pz. So here uh, how to distribute the electrons. So s orbital means carbon p orbital is shifted one electron here. This is a shifted one electron here. Total how many electrons are there? 6 electrons are there. That 6 electrons are filled like this. Filled like this. That means the 6 electrons are enter into the lower energy level. The 6 electrons are enter into the lower energy level. So p orbital also same. Okay. So here, what is the bond order? You can find out the bond order is equal half bonding molecular orbital minus anti-bonding molecular orbital. Bonding molecular orbital minus anti-bonding molecular orbital. So your bond order is equal. Bond order is equal. What is that? Bond order is equal. Okay. Half 1/2 into bonding molecular orbitals are contain how many electrons? 2 plus 2 plus 2. Total 6 electrons. Anti-bonding molecular orbital above the plane. Any is there? 0. That means what? 1/2 half 6. Okay. So this 2, this 6. 2 1 jar 2, 3 jar. 2 1 jar 2, 3 jar. What is the bond order of this? Bond order is equal to 3. Bond order is equal to 3. Okay, means in between the carbon and the oxygen, in between the carbon and the oxygen are bind with the how many bonds? 3 bonds. That is the bond order. So here, which electron pair is donated to the central atom? Which electron pair is donated to the central atom? So this is the homo orbital. Homo means highest occupied molecular orbital. Homo means highest occupied molecular orbital. So this is nothing about the LUMO. Above the plane, one orbit is the LUMO. That is the lowest unoccupied molecular orbital. That is the lowest unoccupied molecular orbital. Okay. Highest occupied and lowest. So this HOMO is contain the electron pair. This electron pair is transferred to the metal. This electron transferred to the metal. Okay. LUMO is the vacate. LUMO is the vacate. That is accept the electron pair from the metal. Accept the electron pair from the metal. Okay. The electron pair acceptor is the electron pair donor. Electron pair donor. Okay. So what about the CO3 bonds are there? So that is the donate electron pair to the central atom CO, which orbit that? That is the HOMO orbit. HOMO orbital is contain electron pair. HOMO orbital is contain electron pair. That electron pair is shifted to the metal. Okay, and this ligand is contain the vacate orbitals. These are the vacate orbitals. That vacate orbitals acts. So yeah, this is also important question. Write the explain the MOED of the CO and homo lumo. Explain homo lumo is the given for the question examination.
Here, explain the homo lumo.
Homo means highest occupied molecular orbital. హలో చెప్పండి. So here that is a total stretching frequency is there, and I will explain that. The range, what is the range for the terminal, what is the range for the bridged, what is the range for triple bridged, all are there here. So sometimes different metals, their different variation is there. So we will give the overall range. Here some different metals is there. They change their different, so slight change their stretching frequency.
Sir, how can I download the notes?
Notes, I will send the notes for the some one group is I will send already. You can ask other. So the next one is the metal nitrosyl. So metal nitrosyl also this is similar to the so this is a MOED diagram of NO. Similarly, CO also there. I will explain only this diagram only. Okay. In the previously I will explain the this only p orbital. S are there. S2 p S orbital contain 2 electrons. Okay. That is the anti-bonding to bonding to. Okay. So like that. Okay. This means this is an actual MOED of all molecular diagrams. MOED of all molecules. Okay. So we can explain S orbital 1s. This is the 1s, 2s, 2p. Okay. 1s is contain, for example, NO. This is a nitrogen atomic orbital, this is the oxygen atomic orbital. Nitrogen also contain s orbital. This is also contain s orbital. 2 electrons are this is contain 2, this is contain 2. 2 are bonding, 2 are anti-bonding. That means total 0. These electrons are not involved in the bond formation. Like that, previously we cannot explain these two diagrams. Actually, the diagrams also included. Okay. So here we can observe the so CO is the 14 electron system. Carbon monoxide is the 14 electron system. 6 electron from the carbon and 8 electron from the oxygen. Total 14 electron system. The 14 electron system is the bond order is the 3. For example, increase the electrons 15, that is the 2.5, 16, that is the 2, 17, that is the 1.5, 18, that is the 1, like that. Or decrease the electrons, for example, 13 electrons, that is the 2.5, 12 electrons, that is the 2, 11 electrons, that is the 1.5, 10 electrons, that is the 1, like that. This is the bond order is 3 for 14 electron system. Bond order is 3 for the 14 electron system. So those molecule, you can count the electron, that is 14 is there, that is bond order is 3. Okay, now here nitrosyl metal is bind with the NO and the formation of metal nitrosyl complex. The formation of metal nitrosyl complex. Okay, so what is the metal nitrosyl? How many? What is the bond order of this? The bond order is this is what is the electron system? Nitrogen is contain how many electrons? Nitrogen is contain 7 electrons. Nitrogen is contain 7. Oxygen is contain 8. Total how many? 15 electron system. 15 electron system. What is the bond order of 15 electrons? That is the 2.5. What is the bond order? That is the 2.5. So the metal nitrosyl is acting as a different binding modes. Different, that is the different binding mode means that is the linear or terminal, bridged, linear or terminal, or bent. Bent also is there. Linear, terminal, bent or bridged. Okay, linear mode, bent mode, and bridged mode. Linear mode, bent mode, and bridged mode. So this is acting as a different donor nature. NO is acting as a different donor nature. They are what? They are what means? That is nitrosyl is contain one unpaired electron also. One unpaired electron. You can observe this here in this diagram. You can observe this MOID of nitrogen. Okay. So here one unpaired electron is there in the antibonding orbital. Antibonding. One unpaired electron is there here. Okay. So one unpaired electron is there. Okay. That means this is acting as a sometimes one electron donor. One electron donor. In that condition, that is bent mode. Okay. Sometimes that is acting as a 3 electron donor. In that is the linear mode. Linear mode. Bent mode is nothing but nitrogen metal. So bent mode is there. NO. Okay, here bond angle is 129 degrees is there. Bond angle is 120. Why? Because of here nitrogen already electron pair is there. Here electron pair is there now. This electron pair is the electron pair and oxygen repulsion is takes place. That means the O is some bent mode. So what is the point now? Nitrosyl is acting as a different binding mode. That is, what is the binding mode of that? Sometimes that is one electron donor, 3 electron donor. For one electron donor is the bent mode, bent. Okay, 3 electron donor is the linear mode, linear mode. Why? Because of metal is bind with the NO. Okay. For example, this NO is single electron donor. So here electron pair is there here. Okay, this electron pair and oxygen, both the repulsions are takes place. That means the oxygen is somewhat change their bond angle, change their bond angle. Okay, like this. So what is the bond angle here? 129 degrees. What about the linear mode? Metal is bind with the N. Linear mode. There is no electron pair is there here. You can observe the both different. Both different. You can observe the different. So here this is the linear. The bond angle is a 180 degrees. Bond angle is a 180 degrees. Okay. Sometimes that is acting as a bridged mode. Sometimes that is acting as a bridged mode. Okay, so metal nitrosyl is the formation of different complexes. They are not perfectly total nitrosyls are not there. So some mixed metal nitrosyls are formed. Thus mixed metal nitrosyls are formed. So here that is this is important. That is bent. That is linear. That means what? Sometimes the metal are require one electron only. That is the donor one electron. Depend on the condition of the metal and the formation of the complex. The one electron is required some metals. In that condition, one electron is donor in this nitrosyl. In that condition, that is somewhat bent is their bond length in between the nitrogen and oxygen. Actually, linear is there. So after bind with the metal, that is one electron donor, one electron donor. In that condition, that is some bent is takes place. That is 129 bond angle degrees. Okay. Sometimes metal is some metals are require three electrons. Some metals are require three electrons. In that condition, the nitrosyl is bind with the metal. Nitrosyl is bind with the metal. In that condition, that is the O and N. The bond angle is the bond angle is the 180 degrees. Bond angle is the 180 degrees. That is the linear mode. That is the linear mode. This is also switching frequency as spectral mode of the spectral means what data. Based on the spectral data, we can explain this binding mode. Sometimes that is acting as a bridged also. Sometimes that is acting as a bridged also. Okay. So now today stop the class. Continue
Sir,
the class. Next session also I will take the afternoon session. Tell.
what is synergism, sir?
Huh?
Synergism.
Synergism.
जी sir. The
Syllogism means the that is I will explain after next class. I will explain that. Okay.
right, sir.
Hmm. So now we'll stop the class.
Jesus.
Hmm.
Right, sir. Sir, afternoon at what time, sir?
I will you I think 1 or 1:30.
Right.
Hmm.
1:30, sir.
Yes.
Thank you, sir.